Hi, so we will be solving electricity block hole, all the paper 2 questions. It will include charges, magnetism, electrical quantities, electromagnetism, motor, generator, and transformer, everything. So we will solve 40 questions today, and it will cover every idea. So question number 696. The diagram shows a circuit containing a cell, a lamp, and 2 ammeters. Current reading on ammeter 2 is 0.2 amperes. So go to the graph, and on the diagram, 0.20 ampere is ammeter 2. So what is the name given to this type of circuit, and what is the reading on ammeter 1? So first of all, you look at that. This circuit is a series circuit because current has only single path to flow. So when current has a single path to flow, this is called series circuit. In series circuit, current has to be same. So current will have same reading in both cases. So if ammeter 2 is giving you 0.2 amperes, ammeter 1 will also give you 0.2 amperes. So answer will be option A. Next question, 97. Which metal is used for core of transformer? We need to use any soft magnetic material. And soft magnetic material in your syllabus is only one, which is iron. So iron is used as the core of transformer, core of electromagnet, core for relay system. Iron is a soft magnetic material. It forms a temporary magnet. Question number 698. The diagram shows a conducting metal rod PQ in magnetic field between the N pole and S pole. The rod is connected to a resistor in a circuit. In which direction should the rod be moved to induce current in the direction as shown in the arrow? First of all, keep in your mind, induced current is in such a way, Fleming's right-hand rule we use. So Fleming's right-hand rule, if you see at my hand, it's like this. So it is the motion, in which direction do you move? Field, magnetic field, and the third one is current. So first of all, notice that they all are mutually perpendicular. They all are mutually perpendicular. So you have to move perpendicular to the magnetic field as well as perpendicular to the current. So first of all, let's shortlist which directions are perpendicular. So first of all, you can see option C is parallel as well as option B is parallel to magnetic field. So only option which is perpendicular is A, because D is the current, C is parallel to magnetic field. Why? Because if you look over here, the magnetic field, when you say north to south, so you can neither choose option C nor option D because they are parallel to magnetic field. So you can only choose the option A, which is perpendicular. So there is no trick in this question. Question number 699. The diagram shows a bar magnet at rest on a smooth horizontal surface. A length of soft iron. Soft iron is magnetic material. It is always attracted to magnets. It is always attracted to magnets. So wire is held parallel to the magnet. Wire is released. What happens? Certainly when you release, it will be attracted towards magnet. So let's see which option is indicating the attraction. A, the wire moves away. No. The wire moves towards. Yes. It is attracted. So attraction will be towards the magnet. Question number 700. Which diagram shows electric field pattern and direction of around the positive charge? Electric field, I gave you a mnemonic PA and T, pant. So PA means positive, the electric field is away. And T, negative is towards. So electric field is away from the positive charge, and these are the radial lines. It is option A. B and C and D are the not radial lines. They are wrong. B is wrong direction. Option A is right. Question number 701. A laboratory has a standard wire of known resistance. It also has other wires made from the same material as the standard wire, but different lengths and diameters. Which wire would definitely have a resistance of less than standard wire? Less resistance. You know, my dear students, the resistance is directly proportional to length. For less resistance, there should be smaller length. Option either C or D. Resistance is inversely proportional to square of diameter. For smaller resistance, should be large diameter. So large diameter option C. Question number 702. The graph shows the relationship between current in a circuit component and a potential difference across it. The graph has a straight section and a curved section. Okay, let's look at the straight section. As long as the current voltage graph is straight, we say resistance is constant. Let's look. Straight line, no change in resistance. After that, there is a curved section, this one. Resistance is voltage over current. If you go for this curved section, there is a greater change in voltage than in current. So if you look at that, the curved section, the voltage changes more, current changes less. So if the voltage changes more, so more the change in voltage, more is the resistance. So resistance increases. Option D. Question number 703. The diagram shows a part of circuit. What is combined resistance of the resistors? First of all, my dear students, notice that these two are in series. These two are in series, you just add the resistors. So if you add 2 plus 1 equals to 3. So series is 3 ohms. Now this 3 ohm becomes parallel with 4 ohms. When 3 and 4 are parallel, in parallel, what do? Combined resistance is the product of 2 over sum of those two in parallel. So 3 times 4 over 3 plus 4, answer is 1.7, option C. First we did series and then we did parallel. Question number 704. The diagram shows a circuit which includes 2 resistors and a battery. The voltmeter reads 6 volts. What is the potential difference across 30 ohms? Dear students, this is called potential divider circuit. In potential divider circuit, keep in your mind, voltage share is proportional to resistance. More the voltage share, more the resistance, more voltage share. Less resistance, less voltage share. If you look at this, for 10 ohms, it is 6 volt. What is the potential difference for 30? So for 30, how much? Crisscross, 10 volt, 10 ohms, 6 volt. 30 ohms, how many volts? Cross multiply. So since if you cross multiply, the x will be 30 times 6 over 10. Answer is 18. There is another way to look. You can see, since the resistance is times 3, the voltage will also be times 3. The answer should be 18. It's easy. Voltage share is proportional to resistance. Question number 705. It's electromagnetic induction again. The wire is moved in a direction perpendicular. I already told you, whenever you want to induce an EMF, the motion should be perpendicular to the magnetic field. All right. So they are making three changes. Three changes are suggested. Okay, the speed of the movement of wire increased. More speed, more EMF induced. Magnetic field strength increased. Stronger magnetic field, more EMF induced. Decreased. So weaker magnetic field, less induced EMF. Direction of magnetic field reverse, no change to value of EMF, but direction will be reversed. So which changes increase the EMF? The only first one. Only the first one. So option B. Okay, the 2 causes less EMF, 3 causes opposite EMF. We need more EMF. EMF can be increased by using more speed, faster speed, stronger magnetic field, or you can use a longer length in the magnetic field. They will all cause more induced EMF in this case. Question number 706. A wire is moved across a magnetic field. This causes an induced current in the wire. So again, we need to have induced current. Okay, so induced current interacts with the magnetic field to produce a force. There is a law in physics called Lenz's law. Lenz's law says that the induced EMF or current causes a force to oppose the change which causes it. Now, what change causes? It could be the motion or it could be the applied current. So it must oppose. It must oppose. In which direction the force acts? Opposite to the motion. In direction of current? No. Direction of movement of wire? No. Opposite. Opposite to the current? No. Opposite to the movement of wire? Yes. Lenz's law says whenever there is induced current will cause a force. This force will oppose the motion. So option is D. Question number 7. 100% efficient step-down transformer has primary voltage VP and primary current IP. Let me tell you what is step-down transformer. Step-down transformer, the voltage decreased, the current increased. If it comes in your mind that why, I can also tell you. The reason is 100% efficient means no loss in power. So power is constant. You all know an equation for power that relates the current. P is equals to VI. So I is equals to P over V. So if step down transformer, if the voltage is less, so current will be more. So secondary voltage will be less than primary voltage, but secondary current will be more than primary current. So secondary voltage will be less because it's step down, but secondary current will be more. Option C. A very good understanding. Let's go to question number 8. Magnetic field of a bar magnet can be represented by magnetic field lines. Which diagram shows 2 magnetic field lines correctly? Magnetic field lines, learn, my dear students, ants. Ants mean AN, away from north. Away from north. TS, towards south. So away from north, towards south. A, away from north, yes. Towards south, yes. Option A is the right option. Magnetic field is away from north and towards south. Option A. Very easy question. Question number 709. A plastic rod is rubbed with a dry cloth. The rod becomes positive. Stop here. Rod is, so if the plastic rod is positive, So it means cloth is negative. So it means the electrons move from the rod to the cloth. So what can you, why the rod has become positive? So I told you the electrons, they move from rod to the cloth. So what's the reason? It has gained electrons? No. It has gained neutrons? No. Lost electrons? Yes. Lost neutrons? No. Actually, during any process of charging, if something is gained or lost, it is only electron. No neutrons, no protons, nothing else. Question number 10. Which statement about electric current in a conductor is correct? Electric current. So let's read. In DC circuits, electric current gradually decreases. DC is direct current. It always flows in one direction. There is no reason the current keeps decreasing. Current can only keep decreasing if somehow you start to increase the resistance or somehow you start to decrease the voltage. Option A is wrong. In DC circuits, free electrons flow back and forth. No. Electrons, they move always from negative to positive, one direction. DC, direct, yani one direction. Option B is also wrong. In AC, electric current remains exactly the same all the time. No. Why? The AC is like that. It keeps changing. It doesn't remain constant. Also wrong. In AC, the flow of charge changes direction continuously. Yes. Why? Look, up, down, up, down. So positive, negative. Direction. AC's definition is the current whose direction keeps changing periodically, continuously. Okay. Option D. A good question, 711 for resistance. A piece of metal wire X with a uniform diameter has resistance R. Another piece of wire Y is made same metal, also has uniform diameter, but this time that double the cross-section area and half the length. Okay, let's do individually. Resistance is inversely proportional to area. Okay, make a table. Here is area, here is resistance. Dear students, they say double the area. So if area is multiplied by 2, inverse mean resistance will be divided by 2. So first thing is, due to area, resistance will be half. Now length. Resistance is directly proportional to length. Here is length, here is resistance, my dear. So if the length is half, length is half, mean length is divided by 2. So resistance will also be half. So resistance is half because of length. Resistance is half because of area. So overall resistance will be divided by 2 and divided by 2. Divided by 2 because of length. Divided by 2 because of area. So overall resistance will be divided by 4. The right option is A. Next question, question number 12. An electric wire is connected to 200-volt power supply. Voltage is V. Energy transfer at the rate this. Kilowatt is not energy. Energy transfer rate means power. So power is kilo mean times 1000. So power is 1000 watt. How much charge passes? Charge symbol is letter Q. In time, 1 hour. 1 hour mean time is 3600. It's an indirect question. I will tell you how do we solve. Charge formula is I multiply by T. Yes, I we don't know. I we don't know, but the time is 3600. So it means we first need to find I. So how can I find I? I will use power and voltage to find current. There is a formula I is equals to P over V. So I is power is 1000, voltage is 2.240, so current is 4.1667 amperes. So dear students, your step 1 was to get the current. Once you got the current, my dear students, now what do? You substitute current here because charge is I multiplied by T, 4.1667 multiplied by that is approximately 15,000. So 15,000, the right option is option C. They wrote in the standard form, which is 1.5 into 10 power 4. Indirect question. So first, what you have to do, first of all, your task was to use the power and the voltage and find current using this formula. Once you found the current, you can substitute in the charge equation, you get the charge. Question number 713. 713 says two lamps are connected in parallel. You can see this lamp and the other lamp. Which switches must be closed? Close means turn on so that both lamps light up. Both lamps light up. Both must have current. Okay, so you should close the master switch so that current can come from the battery. You should also close S3. You should also close S2 so that current can flow through lamp 1 as well as lamp 2. So this means you have to close all the three switches, option D. Next question, number 714. Relay question, it's a good question, indirect question, you will love it. You will love my explanation. The diagram shows a circuit that switches on the lamp when there is a change in environment. Environment change could be two options. Either there is change in temperature or change in light intensity. Yeah, so how we know? Let's discuss. You want to switch on the lamp. You want to switch on lamp. So let's not read the options and understand how this lamp can be switched on. Ready? To turn on this lamp, yes, this switch, first of all, must be closed. This relay switch can only be closed if this electromagnet is very strong. Number two, this electromagnet can only be strong if this voltage share is very high. Number three, this voltage share V2 can be high only if this voltage share V1 is very low. This is number four. Voltage share V4 is only low if the resistance of thermistor, if the resistance of this thermistor is also low. So resistance of thermistor can only be low, number six, if surrounding temperature is high. So answer is high temperature. Let's see, is there any option? So an increase in temperature, option D. Let's go for option. Okay, number 1, 2, 3, 4, 5, 6 again. Okay, so look, dear students, first of all, to turn on this lamp, yes, this switch should be closed. This switch can only be closed if this electromagnet is very. This electromagnet will be only strong if this voltage V2 is very high. V2, if it is very high, it means V1 will be very low. V1 can be only low when the resistance is low. Resistance of thermistor can only be low if temperature is high. The right option is D. This is the best explanation in the history of mankind. Thank you. 715. A step-down transformer is 100% efficient. 100% efficient means input power is equals to output power, no power loss. It has an input voltage 240 and output voltage 60. Label them. Input is called V primary. Output is called V secondary. Current in primary, yani IP. What is current in secondary? IS. So we know the principle VP IP is equals to VS IS, means input power is equals to output power. VP is 240. IP is 0.5. You can divide the Vs on the other side, which is 60. Gives you Is. So you simplify, the answer is 2. So you identify the right symbols. After identifying the symbols, you substitute in the equation, you rearrange, and you get the answer. Question number 716. The diagram shows a pattern of magnetic field due to current in a straight wire. Which row is correct? Direction as well as strength. Okay. So first of all, direction of field. They gave you one of them as this one is looks like clockwise. And X looks like anti-clockwise. Yeah. So how to know direction of magnetic field in straight conductor? We use right hand thumb rule. Right hand thumb rule. Use your right hand and point the thumb in the direction of current. Is this current up or down? Down. Make your right hand thumb down. And look how your fingers are rotating. If you make the right hand thumb down, so look, fingers are rotating clockwise. Fingers are rotating clockwise. So first task is the direction is clockwise using right hand thumb. So X is wrong and Y is X is wrong. So either this or this. Now, relative strength of magnetic field. Strength depends upon spacing. Spacing between the lines. So more spacing, weak field. Less spacing between the lines, strong field. So they want P and Q. Q is very close, less spacing. So Q is strong. P is far away, more spacing, weak. So greater at P, no. No. Greater at Q, yes. Yes. Q is closer, less spacing, stronger magnetic field. Next question, number 17. In which device the magnetic effect of current is not used? All right. Electromagnet itself is the magnetic effect of current. Loudspeaker also uses magnetic effect of currents. Potential divider, it doesn't use magnetic effect. Relay uses the magnetic effect. Potential divider is just distributing the potential based upon resistance, R1, R2. So it says ratios of resistances, same as ratios of voltages. So it has nothing to do with the magnetism. Option is C. The remaining all use magnetic effect. Question number 18. Unmagnetized piece of soft iron is placed close to a strong permanent magnet. You know the permanent magnets, they will attract the iron. So if they attract, so attraction is only possible if near the north you have south pole. Okay, so what pole will be at end X? South pole. And direction of force, of course it is attraction. So if it is attraction, so it is towards the magnet, left side. Option is C. Attraction. So if you are attracting something, it is tending to move towards you. Question number 19. Charging by rubbing. A plastic rod is rubbed with a cloth. Rod and cloth become charged as electrons move between them. Rod becomes negative. Stop here. Rod became negative. What does that mean? If rod is to be negative, so it means cloth became positive. So it means the electrons, they move from the cloth towards the rod. Right option, which is exactly like this, is option B. Next question. Question number 20. A wire has a uniform circular cross-sectional area. Which statement is correct? I already told you that resistance is directly proportional to length. Resistance is inversely proportional to area. Resistance is inversely proportional to square of diameter. All those statements which will match, you can choose. Option A says resistance of the wire is directly proportional to length, directly proportional to cross-section area. Wrong option. It's inversely. B says directly proportional to cross-section area. Wrong option. C says directly proportional to length. Yes. Inversely proportional to area. Yes. C says directly to length, inversely to diameter. No, it is inversely to square of diameter. It is inversely, but square of diameter. Many students may think why D is wrong because it is not squared. 21. The diagram shows the current voltage graph for a metal wire. What can be deduced from the graph? Let me tell you. Today, a question before we studied, as long as current and voltage graphs are straight line. So when the graph is IV graph is straight line, it means resistance is constant. Resistance constant means the temperature is also constant. So let's see constant resistance or constant temperature. As voltage increases, temperature increases? No. I told you if graph is straight line, resistance is constant. Constant resistance means the temperature is constant. So option A says increased temperature. B, temperature decreases. Also wrong. Temperature has to be constant. Option C, as voltage increases, resistance increases. No, resistance should also be constant. As voltage increases, resistance remains constant. So option is D. Now we proceed to next question number 22. A battery is connected to a circuit. It is switched on for 1 minute. Underline the data. 1 minute means time is 60 seconds. During this time, there is a current. Underline I is equals to 0.4 in the circuit, and battery supplies this joules of energy. Energy, underline, it is E. Which row gives the charge? Charge means Q. And EMF means voltage. No problem. Charge formula, my dear students, you all should know that the charge is I multiplied by T. Yes, I is the current, T is the time, you multiply 24 coulombs. Option C or D. EMF is the voltage. Voltage is amount of energy per unit charge. Energy transferred per unit charge. So energy was 48. Charge we found 24, which is 2 volts. Option C. So first we found the charge using the given data, and then energy divided by charge gives you the voltage. EMF is voltage, okay? Question number 23. The circuit diagram shows 2 identical lamps connected in parallel. 3 ammeters, X, Y, and Z, are connected in the circuit. Which statement is correct? This is very easy. These 2 circuits are, this circuit is parallel. In parallel, the total current is distributed. So what is the total current? X. X will be distributed for Y as well as for, so it should be X is equals to Y plus Z. So X is the maximum current, which will be distributed into Y and Z. So they say, what can you say about current in X? I already told you it is sum of current Y and Z. So sum of current Y and Z, you can read the option C, that it is equals to sum of current in Y and Z, because these 2 are in parallel. Whenever components are in parallel, total current entering is equals to total current leaving. So entering is X, leaving is Y and Z. So x is equals to y plus z. Option C. Question number 24. Very easy question. Which switches, okay, the student connects the circuit as shown. Which switches must be closed for bell to ring without lamp? Let's go to the diagram. This one is lamp. This one is bell. Bell should ring, so bell should be on. Lamp should be off. So to make this bell on, current will come here, pass through the bell, go back to the other terminal of battery. So your switch 3 as well as switch 1 should be closed. So option is B. It's so easy. Only these two. 4 is useless. It will make a short circuit. It will even not turn the bell as well as lamp on. So you need to pass the current through bell, nothing else. Option B. Motor, it's generator question. 725. The generator, sorry, it's an AC generator. So the diagram shows AC generator. AC generator means it generates alternating current. First of all, you need to thoroughly read the question, then read the diagrams. It will be easy for you. The graph shows potential difference V between the points X and Y plotted against time. A positive value of PD indicates X is more positive than Y. Okay, so first of all, look at the graph. Point P is a peak value. It is a peak value, mean maximum EMF. Maximum EMF is only possible when coil plane is horizontal. So they say which diagram shows position of P for this graph? So I told you coil must be horizontal for maximum. So coil horizontal, maybe option A, maybe option B is wrong, D is wrong. Now look, one diagram as per the given diagram is wrong. Let's check. Look the given diagram. The given diagram, when the current is coming from the north to south and it connects to what? Y using the upper slip ring. Look, option A. When it comes this way, it connects to X. So this arrangement is wrong. You got it? Now look at C. Comes to the upper one, yes, and to the Y. So this diagram synchronizes the given one. So option is C. It's a good question. I hope you understood. Dear students, question number 726. Which row gives the metal used to make core of electromagnet? Now you already know any type of electromagnet, relay or transformer, they all use soft magnetic material. So soft magnetic in your syllabus is only iron. Only iron. And which property of the electromagnet? So as I already told you, soft means it forms temporary magnet. So iron should be metal and property should be, it should form temporary magnet, option B. Make sense? 727. A plastic rod and a dry cloth both are uncharged. They both are uncharged. The rod is now rubbed with the cloth. They both become charged. The rod becomes negative. Stop here. So if the rod became negative, so it means cloth will become positive. So it means the electrons will move from the cloth to the rod. So what is the charge on cloth? Positive, as I told you. Which particles moved? Electrons, option C. Question number 28. A very good question. You might be confused. First of all, it's anticipated mistake. Students will think the option D. Sorry, not D. Yeah, option D. Student may think the option D. Why they will think D, I will tell you. Look, the question is y-axis is resistance, x-axis is I don't know what. Yani, as x is increasing, resistance is decreasing. Anticipated mistake, students will say, since I is equals to V over R, so if there is more current, there will be less resistance. Actually, this is a reverse relationship. Why? Because when you use this equation, we say R is equals to V over I. Okay? This means R is dependent, I is independent. Okay. Now, this is what students do. So, what you have to do, they think like that when there is more current, there is less resistance. No. Actually, when there is a more resistance, then there will be less current. Resistance high, current low. But it doesn't mean if you make more current, resistance will decrease. No. So, I will tell you what's the main concept. First of all, it is something is increasing, resistance is decreasing. Diameter of wire, let's check. More diameter, less resistance. Yes, it is correct. Length, length graph should be straight line. Directly temperature. Temperature says more temperature, more resistance. Now, why this option is wrong, I will tell you. D. The reason is current. If there is more current, there will be more temperature. And if there is more temperature, the resistance should increase. For thermistor, it will decrease. If this is thermistor, it is correct. So that's why option is A. Next question, question number 729. Cost of electrical energy is $0.25 per each unit kilowatt hour. Kilowatt hour is the unit of electrical energy. Now, 2200 watt power is switched on for 48 minutes. Electrical energy first we find to find the cost. Energy is power multiplied by time. Since the given unit for energy is what? Kilowatt. So let's change that also into kilowatt. So the power, first of all, I will change from watt to kilowatt. I'll divide by 1000. So power is 2.2 watt. 2.2 kilowatts. Time is minutes. I will change into hours. Divide by 60. So time is 0.8 hours. You have the time, you have the power. Electrical energy will be power 2.2 kilowatt, time 0.8 hours. So energy is 1.76 kilowatt hours. This is the total energy provided. Now do cross multiplication as per the given situation. In the question, they told you $0.25 is for 1. So 1 kilowatt hour, $0.25. 1.76 kilowatt hours, how many dollars? The answer will be A. Question number 730. Table describes 4 different resistance wires. They all are made from the same metal. Which wire has the smallest resistance? Smallest. Resistance directly proportional to length. Resistance inversely proportional to square of diameter. Smallest mean less resistance, less length. Less length, either A or B. Diameter. Less resistance requires more diameter. More diameter, option B. Question number 31. Again, easy switching circuit. The circuit shown contains 3 switches and 4 lamps P, Q, R, S. Which switches must be closed so that lamp P and R are on? Connect the circuit. P on, R on. Which switch is on their path? Only switch 1. Only switch 1. For lamp P and R, there is no other switch in their way. 32. The diagram shows the magnetic field around the solenoid carrying an electric current. What happens to the strength of magnetic field and distance between them when current is increased? More current, stronger magnetic field. And if there is more current, magnetic field is stronger. Stronger magnetic field means closer the lines. Closer the... So lines closer mean distance between them will decrease. Lines will get closer. Narrow. So when lines get closer, the distance between lines will decrease. Less spacing, stronger magnetic field. Number 33. Diagram shows a wire hanging freely between the poles of a magnet. There is a current in the wire in the direction shown. The magnet and current cause the force to act on the wire. In which direction does the force act? First of all, force due to current, you use Fleming's left hand rule. Fleming's left hand rule. Fleming's left hand rule, as you can see, here is the Fleming's left hand rule. Force, field, current. We say F, force, B, magnetic field, I, current, F, B, I. Force, field, current. So force should be perpendicular to field and current. So look, magnetic field is north to south. Current is down. So it means the force can be now either out of the page or into the page. So not to the left, not to the right. 2 options are left. Apply Fleming's left-hand rule. First thing is position the index finger from north to south. Okay, this is index finger from north to south. This is from north to the south. Then the current is going down. Index finger down. Index finger down. Index finger. This second finger is the index finger. Force field. Sorry, field is north to south. Second finger, the middle one, down. So north to south, down. So this is into the page. This is into the page. Again, force, field, current. Field is north to south towards your left. Current down. So thumb is into the page. So into the page means away from your eyes. Question number 34. Which component forms a part of DC motor but not the AC generator? These are split ring commutators. DC motor has split rings. Generator has slip rings. So DC motor has, generator doesn't. Both have coil, both have brushes, both have magnets. Last question. Transformer has 5,500 turns at primary, NP. 500 turns at secondary, NS. Output coil, output yani VS. VS means secondary voltage. Yes? The output of secondary coil and transformer is 100% efficient. Indirect, difficult question. The heater produces the power this. What is the current in primary? To find the current in primary, you can directly use the power because it is 100% efficient. So input power should be same as output power. If the output power is 132, input should also be 132. No power gain, no power loss. So you know input means primary voltage. Do we have? No. Primary current? Do we have? No. So there is a problem. So it means we need to find the primary voltage first. You know the ratio of voltages Vp over Vs, Np over Ns. Primary voltage we want to find first. Secondary voltage is 110. Primary terms are 550 over 500. 2 zeros simplified. So this goes there, which is 55 over 5 times 110, which is 1210 volt is primary voltage. Now go here, 1210. You know power P is equals to VI. So I will be P over V. The power is 132 over 120, which is 0.109, which is approximately 0.11, option A. Thank you very much. These 40 questions are very useful in your any exam paper 2 for electricity. Thank you.